In this video, I want to talk about solving triangles in the side-side angle case, or SSA. And please, when writing it down, always say side-side angle, because when we abbreviate it, if you try to say it the other way, which would still be true, it is angle, side-side, you know, an angle and then two sides in a row. But if I try to write that the other way, YouTube will block the video. So we're always going to write SSA for the side-side angles, even though, as I think about three examples in this video, I am going to think about an angle first and then the two sides. Now, what's most important about this, side-side angle means I know two sides and one angle, but not the angle between the two sides. And if I think about the triangle that we like to draw with vertices A, B, and C around it, making that little a, little b, and little c, right? That's angle alpha there, right? So if I look at the parts of the triangle I'm given alpha, c, and a. I'm given a side, an angle, and then two sides. It's not the angle between them. And if I now think about sides C and A, I know the side between them has to be beta, right? Because C and A are across from gamma, across from alpha, right? Beta's across from the missing side B. If I think about it, if I know A and C, what angle's between them? Beta. It's kind of the thing not said, right? Little a, little c, the angle at vertex B is what's between them. And so I'd have this side-side angle case if I knew either alpha or gamma here. All I know for sure is it's not beta if I'm dealing with a side-side angle, that SSA case. All right, in this video, I'm actually not going to solve any of these triangles. In this video, I just want to talk about how many solutions we can have in this side-side angle case, because it is actually what we call the ambiguous case, because it turns out there can be 0, 1, or 2 solutions. And when we're asked to solve a triangle, well, if there's 0 solutions, we should figure out that there's no solutions. If there's 1 solution, we should find it. And if there's 2 solutions, we should find both of them. And the reason we should find both of them is whenever we're asked to solve something, that's actually a request to find all of the solutions. So I have one of each here, so we can just think about why there might be 0, 1, or 2 solutions. So I'm going to start with this example, and I'm just going to imagine having a straight edge down here, and I'm going to draw a 35-degree angle first. So I'm just going to imagine that I have this nice happy triangle, and I'm thinking about 35 degrees, 5 inches, and 5.5 inches, and I'll start just with a straight line down here. And at this edge, I want to draw a 35-degree angle. So I actually want to do this pretty well to scale. It probably won't be perfect, but it'll get the point across. And so let's see, 10, 20, 30, 35 degrees. So I get an angle coming from that vertex through that point, and it's supposed to be 5 inches long. And I put tick marks on my straight edge here that are in inches. All right, so 1, 2, 3, 4, 5 inches long. There's that 5-inch side. And just in case you think I'm cheating and didn't put good tick marks on that, I did bring something that is actually ruled. And maybe just a little long, so we'll just take a little off of there. There's my 5-inch side. All right, well, I drew angle alpha here, right? That was a 35-degree angle, which makes that side A, which means little a is going to be over here, and I want this to be that 5-inch side. So that was 5 inches, that's C. All right, that puts B up here, because C, puts gamma down here. So wherever gamma is has to be on this horizontal line I've drawn. All right, so now I want to imagine a 5.5-inch long side. And so on my nice ruled tape measure here, 5.5 inches is right there. And so I can imagine attaching it up here, right? Because that's where side A would attach. And I can imagine forming a triangle just by seeing where that 5.5 inch would hit my horizontal line, right? So I need to extend my horizontal line because apparently it's not long enough. And go back and mark that 5.5 inches here for side A that's across from vertex A and angle alpha. I attach it to the top, and again, if I can make it hit that that horizontal line, there's a solution. There's a triangle that works with the given information. 35-degree angle, side that's 5 inches long, and now a side that's 5.5 inches long. And if I continue to swing this around, it never hits that horizontal line again, right? At 5.5 inches, it clears that vertex over there, and I just get this one solution right here. All right, so let's mark where vertex C is going to be. B was up here. And now I know I'm going to find one solution, because that was the only place my 5.5 inch long side would work, where I would form a triangle with angle side and knowing that side too. All right, so now I have A is equal to 5.5 inches, which was given. There's my side angle. All right, well, if I'm asked to solve this triangle, I'll need to find side B, angle beta, and angle gamma. And I'll be able to use the law of sines to do it. But apparently, this has just one solution. So now, I just want to go through the other two examples, drawing pictures. I'm going to solve each one of these in the next 3 videos. But in this video, my only goal was to see how many solutions there would be. And here, I have a side that's just kind of the right length, that I can form this one nice happy solution. Nowhere else I would hit the horizontal line until I get to the other side, but that doesn't have the 35-degree angle in it. So I have just that one nice happy solution. So now I want to imagine that little a is only 3.5 inches long. So I'm going to erase this side. And I think I can imagine that that's not where C is going to be. So let's just see where it should be. So there's my 3.5 inches on this little tape measure. And I rotate down, and hey, there's a solution right there, where at 3.5 inches, I've hit the horizontal line. So I feel good about that, and there is a triangle that solves that given information. And then I keep swinging, and hey, there's another spot where I would hit that horizontal line. And so I don't see one triangle that works, now I see 2. I see this triangle, where over there at vertex C and angle gamma, I have an acute angle, and I could think about that as being called little c1, still have vertex B up here, and then over here there's another point that works, I could call that c2. So I have an acute angle gamma 1, and I have an an obtuse angle gamma 2. So I have one triangle, and then I didn't do a good job of drawing a straight line there, but I have a second triangle that works. And so apparently, with this given information, I have 2 solutions. We would need to find them both. All right. And a video solution to that posted just after this one. And then finally, I want to imagine what happens here. And I think you can probably figure out, right? I had one solution, I had 2 solutions. This has to be the 0 solution one. And I have a feeling you even can kind of like predict what's going to happen. So I go to 2 3/4 of an inch right there, and I try to attach that there. And just anywhere I swing that down, that 2 3/4 mark never hits the horizontal line. It's just too short. And that's how you could have information that looks like this that gives you no solutions. All right. So in this video, all I want you walking away from it thinking is, hey, if I have side-side angle, I could have 1 solution, 2 solutions, or 0 solutions. One solution is like I have a side length over here that's just the right length to hit that horizontal line just once. 2 solutions, it's like I have this side that is just right now to hit it not in one place but in a second place as well. And then in those solutions, it's like I have a side that's so short that it can't hit the horizontal line at all. Almost like that angle's too steep. Now the question I hope you have for yourself is, hey, when I'm solving one of these, how do I know how many solutions it has? And we'll see that come up as we solve each case. In the next video, I'm actually going to go on and tackle the big one that has 2 solutions first.